So first question we'll take a look at is finding roots of a polynomial. Whenever we want to find the roots, we always set the equation equal to what number?
0.
Yeah, so basically this is what we're trying to figure out. And because it's a cubic, that tells us that this problem is going to have how many answers?
3.
3. Yep, going to have 3 answers. Now, since it's a cubic, can we use quadratic formula on it?
No.
No. The only thing we can do first is find the rational roots and then divide through by one of them, and that'll turn the cubic into a quadratic.
Okay, and we need to quadratic.
Then we can use quadratic formula. Yep. Okay, so let's start with our P's and Q's. So P is all the factors of the constant. What are all the factors of the constant here? I mean, what is the constant?
Negative 69.
Negative 69. So the factors of that would be plus or minus 1. 2 doesn't.
Yeah, no, that's a...
But 3 does.
So much.
I don't think 4, 5, 6, 7. I think, yeah, it's going to be 1 and 3, and then 3. What's 69 divided by 3?
That should be... it's 23?
23. Yep.
Plus or minus 1.
So I think those are pretty much going to be our factors of
Negative 69.
negative 69.
And then
Now,
1 is just plus minus.
right. The leading coefficient, the factors of that are just plus or minus 1. So my possible rational roots are all the P's over all the Q's, but Q is just 1. So the Q doesn't really affect anything.
So it's plus or minus 1 over 1, 3 over 1, and 23 over 1?
Yep.
So it's just the numbers.
It's really just the P values.
Okay.
Okay. Now we need to narrow that list down. How are we going to figure out out of those 6 numbers, which ones work?
Which ones work?
Yeah, how are we going to narrow that list down?
So, give me a second. Possible rational roots. Okay, I kind of. Let me look at this. Should be fine.
So what we want to do now is graph that.
Graph it.
Right. We want to graph that,
Okay.
and that's going to help us to narrow down which numbers are going to work.
Oh, so we're just trying to figure out what intercepts match the possible rational roots?
Yes.
Okay.
So
Got
we
it.
have x cubed minus 10x squared plus 44x minus 69. And I'm going to do zoom. Well, I'm going to set my window on my x-axis to go from negative 25 all the way to 25, just in case it crosses at 23.
Okay.
Okay. So out of all the choices we have listed, which one seems like it could be a possibility?
3.
Yeah, I would say 3. So let's go to trace, press 3, and yes, it is. So when we trace to 3, we get a root. So let's start making a list.
Got it.
So over here, we'll put our roots. So we have 3. And now, what are we going to do with that 3 to turn this cubic into a quadratic?
Synthetic?
Yep. So we're going to divide through by the root. So we put 3. What would be my coefficients for my numbers on the inside?
1,
Yep.
negative 10, 44, negative 69.
Perfect. Okay. Let's do this out. Bring down the 1. What's 3 times 1?
3.
Negative 10 plus 3.
That's negative 7.
7. 3 times negative 7.
Negative 7. So negative 21.
Negative 21. Add those up, and we're going to get
Negative 23. 23.
23. What's 3 times 23?
23, that is 69.
69. Add those up, and we get
0.
Perfect. So that proves that 3 is a root. And now, if we were factoring this problem, if 3 is a root, that tells me that what is a factor?
Now, what is the factor? X minus 3?
Perfect. So that's one of the factors, and the quotient is the other one. X squared minus 7x plus 23. So now, essentially what we're doing, because we factored it, we're setting each factor equal to 0 and we're solving.
Okay.
We've already solved the first factor. We know x is 3. Okay, we got that. Now we got to figure out what would make that 0. Now, that doesn't look factorable to me. So how are we going to be able to solve for what makes that 0?
Quadratic formula?
Yep. So we're going to do quadratic formula. There's your a, b, and c.
Yep.
So we've got negative b plus or minus square root of what goes under the square root.
What goes under the square root?
Yeah.
Divided by 2 times a. Oh, okay, that's, since that's b, that's going to be the negative 7?
Squared. So
Squared, yeah, negative 7 squared.
b squared.
Minus 4 times 1 times 23.
And all of that is divided by?
It's going to be 2.
By
That's
2.
2 times a.
Yep. So let's do that out. 7 plus or minus 4 times 1 is 4.
And
4
then-
times 23 is, how much is that?
Well, that's going to be 80, no, 90, no, sorry. Negative 82. No, negative 92.
92.
92. Okay,
Yep. So that gives us negative 43 divided by 2. And when we simplify that, we got to take that negative out of the square root. So how do we write the square root of negative 43?
Right, 7 plus or minus 40, no, the square root of 43i.
Yep, and we'll just put the I in front so we know that it's not under the root.
Okay.
Those are the other two answers. If they wanted them in standard form, you put the real part over 2, and then you put the imaginary part over 2 separate. So remember, this is what I just put a box around, that is standard form.
Okay, let me write this up now real quick.
And these are my other 2 roots.
Okay, so the 2 different roots are 7 over 2, and then plus or minus negative, no. The roots are 7 over 2, and then it's going to be negative and positive square root of 43 over 2i.
That's 2 of them, and the
Okay.
third one is 3.
Okay,
Those are my 3 roots.
let's write this down real quick.
Yep.
Thank you. Right, and then
Okay, so for the next one, we're going to look at finding all possible rational roots. So we're going to list out all the p's and q's.
Good.
So let's start with p. P is all the factors of the constant, which in this case would be
12.
that's one of them. Yep, plus or minus 12. I'll put that over here.
Oh, that's a problem. There are 12. I put that one. There's plus or minus 1,
Yep.
plus or minus 2, plus or minus 3, plus or minus 4, and plus or minus 6.
Plus or minus 6
And then the plus minus 1.
and plus or minus 12. Okay, so those are all the different p's. And how about the factors of q?
Plus or minus 1 and 2.
Plus or minus 1, plus or minus 2. Okay. So to list all the possible rational roots, we have to list all the different p values over all the different q values, and we might get some repeats. Okay, so let's make our list. So let's start with a particular p value, and let's put that over both the q values.
Okay, so that'll be 1 and plus or minus 1 and 1.5.
Plus or minus 1,
And a half.
plus or minus a half, so that's that one. Now let's go to this one and list that one.
It would be, this would be 2.
2
Or
and,
1. 2 plus or minus 2 and 1.
so 2, yep, and what else?
and then 1 because
1.
2 over 2. That would count.
But what about 1? Should we write that one down?
The 1 and the 2
So we have, 2 and 2 over 1 and
is
2 over 2.
Is 1.
Okay.
Plus or minus.
So should we write that one down?
Oh no, we already have that one.
We already have that one.
Okay. Oh, that's what you're saying.
Okay. What would be the next one?
It would be 3,
Yep, 3 over 1
and then it would be 3 over 2.
and 3 over 2.
Write some of these down.
Okay. What about the next one?
Let me write some of these down and okay, 3 over 2. So the next one is going to be 4 plus or minus 4.
Plus or minus 4 over 1, and
And we don't have to write down because we already have 2.
we already have 4 over 2.
Yeah.
Okay. So next one?
Next one will be 6. And we already have plus or minus 3.
Yep, so it'd be 6 over 1, 6 over 2, but we already have 6 over 2 is 3.
3.
And the last one?
It would be 12.
12 over 1, yep.
And then it would be, we already have 6. So we're
Yep,
good.
so then it would be 12 over 2, but we already have that one as 6. So these are a list of possible rational roots. And if we were going to solve this problem to actually find the roots, how would you narrow this list down?
Put in the calculator
Right.
and see what intercept it matches up with one of those.
Yep, we would graph that. And remember, it might be none.
Yeah,
If-
it's possible.
It's a possibility that none of these actually work, and then we'd be stuck. We wouldn't be able to solve it, which is why we're not going to solve this one. So let's set our window from, I would do negative 15 to 15.
Okay.
Then we can see all the roots.
Negative 16. Okay, graph.
And, okay, out of the numbers that we have listed, do any of them look
Negative 3.
reasonable? Yeah, I would say you could, I mean,
Wait.
it looks like it's between.
Negative 2.5. We don't have that.
Yeah, we don't have negative 2.5. The closest one we have, I think, is negative 3 or negative 2.
Yeah.
Other than negative 3 or negative 2, I don't think any of them are a good fit.
Yeah, it's like negative 2.5 to
Yeah.
5. Yeah, no.
So if you wrote, yeah, really in this problem, I don't think any of those numbers are going to work. So we didn't do anything wrong. Those are our rational
Yeah.
roots. It's just they're all eliminated, which means this root is probably what kind of number?
Irrational?
It's irrational, yeah, because it's not in this list. So whatever it is, it's a number that cannot be written as a fraction.
Got it.
Yep.
Okay. So irrational.
So the next one, we're going to take a look at finding the remainder, but we're not going to use long division or synthetic division. We're going to use the remainder theorem.
Okay.
So to use the remainder theorem, first of all, it has to be x and minus and then a number in that box.
Okay.
Whatever number is in that box, you're going to take that number and fill it into what's in the top.
Got it.
Okay, so let's look at ours. Is this one set up in the denominator as x minus a number?
Yep, x minus 2.
Yep, so what number is in the box?
It is a 2.
2. So we're going to take a 2
And plug it in for x.
plug it in for x everywhere we see it in the top.
Okay.
So 2 cubed minus 8 times 2 squared plus 6 times 2 minus 4. And let's do that out and see if it works.
Got it.
What's 2 cubed?
2 cubed, that would be
8. 2 squared,
8. It would be 4.
4 times 8,
4 times 8, that would be 32.
32. 6 times 2,
That's 12.
12. All right. What's 8 minus 32?
8 minus 32, that's 24.
Well, careful because it's 8 minus 32.
Also negative 24.
So it's going to be a negative 24. And then plus 12 minus 4. What's negative 24 plus 12?
Plus 12, that is negative 12.
Negative 12. And negative 12 minus 4.
That is negative 16.
negative 16. So that is the remainder when we divide the top by the bottom.
Okay. So the remainder is negative 16.
Negative 16. Now, because we got a remainder of negative 16, what does that mean about x minus 2 compared to the top?
Compared to the top.
Yeah. We got a remainder of negative 16.
Does that mean that's...
So we divided two things and we got a remainder, which means this is...
the quotient? No, that wouldn't be it.
What does it mean when you divide two things and you get a remainder that's not 0?
That's not zero. That means that it's not a... what's the word? It is not a root?
2 is not a root, but x minus 2 is not a...
Rational number?
No, not rational number.
I mean,
When you divide by, like, if you think about when we did the p's and q's, we were listing all the what?
the rational roots.
Yes, but when we started with p, we listed all the...
Oh, the roots of the constants?
Not the roots, we listed the factors.
Factors, okay.
Yeah.
So that means that x minus 2 is not a factor?
Right. That means x minus 2 is not a factor of the numerator.
Okay. Let me write that down.
Exactly.
Thank you.
All right, so now we're going to take the same problem that we just had, and we found the remainder, but let's do long division just to practice doing that, and that'll give us the quotient and the remainder.
Okay.
So we should get a remainder of negative 16 when we do this. Okay, so long division, we're going to start with x cubed divided by x.
That's x squared.
X squared. And when we multiply that back out, what do we get?
Let's put this down there. It's going to get x cubed,
Yep.
and then minus 2x squared.
Okay, perfect. And now what do we do with those columns?
Oh, we subtract.
Subtract them. X cubed minus x cubed is gone. What's negative 8x squared minus 2x squared?
That's going to be plus, so it's going to be 10x squared.
So negative 8 plus 2.
Oh, no, plus 2, right. Negative 6x squared.
Negative 6x squared. And what do we do next?
We add the plus 6 squared and the minus 4 down.
Yeah, just bring down the 6x.
The 6x.
Yeah.
Okay.
Bring down the 6x.
That's what we're going to do one. Okay, thank you.
All right. Now, what's negative 6x squared divided by x?
Do the math out real quick. Negative 6x squared divided by x should be negative 6x.
Yep, that's good. Okay, multiply that back out. Again, negative 6x squared. And what's negative 6x times negative 2?
That'll be negative 12, no, 12x.
12x?
Yes, plus 12x.
Good. And now what do we do with those columns?
Subtract.
Perfect. So we'll subtract that. Negative 6x squared minus negative 6x squared is gone.
Cancels out.
What's 6x minus 12x?
It's going to be negative 6x.
6x. And what do we do now?
We bring down the 4. The negative 4.
Bring down the 4. Yeah, negative 4.
Now we do negative 6x divided by x, which is
Yes.
going to give us negative 6.
Negative 6. Now multiply that back out.
We do negative 6x
Yep.
plus 12.
Plus 12. And we're going to
Subtract.
subtract.
Going to cancel out the negative 6x.
Okay. And what's negative 4 minus 12?
Negative 4 minus 12, that would be. Give me a second. I might think this is. Oh, no, negative 6. No, 6.
16.
Negative 16. My bad.
Yeah. So negative 4 minus 12, that will give you negative 16. And what is that negative 16?
The remainder.
That's my remainder.
And that matches up with the top.
That's exactly what we got at the top. We just found it a lot faster the top way.
Okay.
But the bottom way took longer, but it also gave us something else.
The quotient,
It also gave us the quotient.
which is x squared minus 6x minus 6.
Yep. Now, we could do that same thing one more time, except we could use synthetic division. So if we do synthetic, what number would go on the outside?
Say?
When we're doing synthetic, what number would go on the outside?
What goes in something synthetic? That would be the negative 16?
So for our original problem, we're going to do this original problem again.
Oh, we're doing that again. Okay.
Yeah.
So, let me look over this again. We would take one of the roots.
Put the number after the minus sign.
So that's going to be 2.
So 2 goes on the outside,
Yeah.
and what numbers would go on the inside?
Just like 2. And then it would be 2. Give me a second, I'm trying to look at my head.
Remember, these are from the original problem. They were given to us.
Sorry, 1,
Yep.
negative 8,
Yep.
6, negative 4.
Negative 4. Okay. So what's our first step with synthetic division?
Bring number 1.
Bring down the 1.
2 times 1 is 2.
2.
Negative 8 plus 2 is negative 6.
Okay.
Negative 6 times 2 is negative 12. 6 plus negative 12 would be negative 6.
Perfect.
And then 2 times negative 6 is negative 12 again. And negative 4 plus negative 12 would be negative 16.
Negative 16.
And that would be our remainder.
Exactly. Negative 16 is your remainder. And the 1, the negative 6, and the negative 6, those are the coefficients of the quotient.
Okay.
So there's 3 different ways you can find the remainder in a problem. Remainder theorem is definitely the fastest. But if you also need the quotient, synthetic division is pretty fast as well. So since we did that 3 different ways, and we got remainder negative 16 each time, can you tell me one more time, what does that mean about x minus 2?
That means that that's not a factor.
Not a factor of...
The x cubed minus
Yeah.
8x, yeah.
Yep, it's not a factor of that numerator.
Yeah.
If it was a factor, what would have happened when we did these problems out?
Say again? Oh, it would equal 0?
What would be 0?
The remainder.
Yes. If we had done this out and gotten a remainder of 0, then we would have shown that x minus 2 was a factor.
Yep.
All right, so this one we're going to take a look at finding a polynomial that has certain roots. Okay? This one we'll do with imaginaries, then we can do one after that has reals.
Okay.
So if we know 3 plus 4i is a root, what would be the factor that that came from?
X minus 3 plus 4i.
Yep, and it's important we put that 3 plus 4i in parentheses.
Got it.
So it's always x minus the root. And what about 3 minus 4i?
It would be x minus 3 minus 4i.
Yep. Now, both of those have a negative in front of the parentheses, so what do we have to do with that negative?
Second?
What do we have to do with that negative?
Negative. We have to distribute it.
Yep. And what would you get when you distribute that out?
It would be x times negative 3.
So x minus 3
Sorry, x minus 3 plus 4i.
minus 4i. Because you're distributing that negative to both.
Okay.
How about the second one?
It would be x minus 3 plus 4i.
Yep, good. Now we've got to multiply all of that out. So let's start with x times x.
X squared.
X times negative 3.
Negative 3x.
X times 4i.
X, that's going to be 4xi.
Yep,
4ix.
yeah, same thing. Yep. Okay, and now how about negative 3 times x?
Negative 3x.
Negative 3 times negative 3?
That would be 9x. No, 9.
9. And negative 3 times 4i.
Negative 12i.
12i. And the last one, negative 4 times x.
Negative 4x.
Careful, negative, I'm sorry,
Oh,
negative,
negative 4i. That would be negative 4ix.
yeah. And negative 4i times negative 3?
It would be 12i.
12i.
Plus.
So I'm gonna put that over here. And negative 4i times positive 4i. Well,
It would be negative 16i squared.
perfect. Okay, now before we deal with that I squared,
So does some things get canceled out?
yep, what's gonna cancel out?
The positive and negative 4ix.
Positive 4ix, negative 4ix, yep.
The positive and negative 12i.
Positive 12i, negative 12i. So those four things always disappear.
Okay.
Now you're left with x squared.
Okay.
What's negative 3x minus 3x?
Negative 6x.
Negative 6x. And we have 16i squared. Do you remember what we said I squared was?
Negative 1.
Perfect, negative 1. So really here, we're subtracting a negative, so that's going to become a positive.
Okay.
So what would we get for our final answer?
It would be x squared minus 6x. Is that plus 25?
Yep. That would be a polynomial that if you use the quadratic formula to solve it, you would get 3 plus 4i and 3 minus 4i is the answers.
Alright, so okay, so we'll circle back. Got it.
Yep.
Got it.
Now, let's do it with reals, and that way we can also then verify that one of the numbers is a root, which would be the last topic.
Got it.
So let's say that 4 was a root and negative 5 was a root. It's a little bit easier with reals because you have less to multiply. If 4 is a root, what would be the factor that comes from?
X minus 1.
Good. And if 5 is a root, that
X minus negative 5 would be x plus 5.
yes. Now let's multiply that together. X times x,
X squared
x times 5,
minus 20. No, sorry. X times 5 is 5x.
5x minus 4x.
Minus 4x equals x
And negative 4 times positive 5,
equals negative 20.
Negative 20.
Minus 20.
okay. So there's another one. That one also was a quadratic. But if you used quadratic formula or factoring on it, you'd get 4 and negative 5 as the answers.
Okay, so if we just so to check, we can plug it into the quadratic formula.
Yeah.
And then if it goes back to what it originally was, I mean, that is
Yeah.
correct.
Now, we're going to check that 4 is a root
Okay.
by hand. So let's pretend that we didn't know what we've already done. Okay, let's just say I gave you that problem, x squared plus x minus 20, and I said check if 4 is a root. Well, checking if 4 is a root is the same thing. You could do the same thing by checking that what is a factor. So if 4 is a
X
root,
minus 4?
yes. So what we're going to really do is check if x minus 4 is a factor. Now, how do you check if something is a factor of something else?
You plug it in to the original. Oh no, we're only giving the roots. Alright, so
So if something is a factor of something, what does that mean will happen when you divide them?
that means it will equal 0.
What will equal 0?
The remainder.
The remainder. So let's divide these quickly and see if we get a remainder of 0.
Okay.
Now, well, actually, we can do it a couple ways. We can either divide them synthetically and see if the remainder is 0, or we could use the remainder theorem. We could do this a couple different ways. How do you want to do it?
Let's do it with. Let's do synthetic division.
Synthetic division. Okay. So what number would you put on the outside?
We would put the 4.
4 on the outside. What number is on the inside?
The numbers would be 1.
Mhm.
It would be 1 again.
Yep.
And it would be negative 20.
-20. All right.
Put the 1 down.
Bring the 1
4
down.
times 1 is 4. 1 plus 4 is 5. 4 times 5 is 20. Negative 20 plus 20 is 0.
Okay. And that 0 is my what?
Is your remainder.
That's my remainder.
Factor.
So that means 4 is a what?
4 is a factor of the.
Nope. 4 is a.
How do I refute the let me get that. I got it.
So there's a difference between saying 4 is a something and x minus 4 is something. But different terms, terminology.
4 is a root.
4 is a root, which means x minus 4 is a
Factor.
factor. Yes.
So if 4, okay.
So we've now shown that 4 is a root.